This is Mr. Anderson for Kellogg Community College. Today we are going to look at all the different parts of Chapter 2, Section 6, and we're going to introduce phase shift to you. We're going to review just some of the older parts of the problems that we've been manipulating to get sine, cosine, and the other functions graphed here. We're going to look at a, which is the number in front of our sine or cosine function, and this was our vertical stretch. And the vertical stretch allowed us to do the graph faster or slower, and the amplitude is going to be the absolute value of a. B is going to be our vertical shift to shift the graph up and down several whole number units. And we will look at an example on the page with that. The period is a combination of these two pieces here because we've talked about omega before. And in the previous section, we've looked at this omega, which affected the period because we took our 2 pi and divided it by our omega right there. This omega influenced the cycle, or period, depending on which way you wanted to call it. So this is a cycle or a period influence. And then this new Greek symbol is called phi, pronounced Fi but written as Phi, and this is going to influence the phase shift, which is more of a horizontal influence here. So the phase shift influence. So if you want to think of the vertical stretch and vertical shift here, this would be more of the horizontal stretch, or omega, and phi would be the horizontal shift, left to right. To perform a phase shift, you're going to take your phi and divide it by your omega. So in this next problem we're about to do, this will cover all 4 pieces of our vertical and horizontal motion. This problem has an A, it has a B, so we're going to have a vertical stretch and vertical shift. It also has an omega and a phi, and this is going to influence the cycle by stretching the horizontal. In this case, we're going to make it twice as fast, so this is going to shorten the time of 2 cycles, and then we will shift this pi units over. I'm going to use 4 different graphs to show the slow progression of this. Okay, for this problem, what we're about to do is we're about to do the 4 parts of this, of graphing this. And I'm actually going to combine the first graph with the a value, which is the absolute value of a is 3. So this is going to be my amplitude part of the problem. I'm going to graph 3 sine of x. Now this is going to be 3. This is going to be negative 3. And I'm going to put extra tick marks in here because I want to complete 2 full cycles. I want to go from pi to 2 pi, because the sine wave will go in pi over 2 units of distance, 3, and then down to pi, comma 0, and then this is down here 3 pi over 2, and then to 2 pi, it lands back again at 0. Now I'm not plotting all 5 points like I normally do this in my homework assignment, because I'm just getting my original graph down for my a value in front of the problem. For my next problem, I'm going to graph y equals 3 sine of 2x. I'm going to use that omega in front of the x to figure out what I'm going to graph, or how I'm going to graph this. Now, this is different than some educators are going to have the students do the graphs. Oops, I just missed my dot there. Do the graphs here by actually transforming them. But what I like to do is I like to graph the same picture as I did before, and then I let the points do the talking. See, 2x tells me I'm going twice as fast, so I'm going to complete my 2 cycles in half the time. This ended at 4 pi over here on the left side, because if 2 pi was the halfway point of this graph, then 4 pi would be the 2 cycle finish line right there at 4 pi comma 0. So let's take a look at this here. This is not going to be pi over 2. In fact, this interval from here to the first tick mark is pi over 2, and we're going to divide by the omega 2. We're going to divide by that omega 2, which is the same thing as multiplying by 1/2, so we get an answer of pi over 4. So this first step here, this pi over 4, is going to be at 3 for my a value. Then this here is going to be pi over 2, comma 0. This down here is going to be 3 pi over 4, comma negative 3. There's my negative 3 there. So every step here is now marking a quarter instead of a half, pi units. So this is going to be 4 pi over 4, or just pi comma 0. This is going to be 5 pi over 4, comma 3. This is 6 pi comma 4, or 6 pi over, or sorry, 3 pi over 2, comma 0. And then 7 pi over 4, comma negative 3. And then finally we have 8 pi over 4, comma 0, or 2 pi, comma 0. So you can see that we have went that entire span, but we went that entire span in half the time, from 4 pi down to 2 pi, even though this represents 2 cycles. Okay, so for my third picture here, we're going to tackle our phase shift. And so from the problem, we take our phi, and we divide it by our omega. Again, let's put up the part of the y-axis that's important. But this is one of these graphs that I actually don't copy from the previous picture, because what I need to do is physically shift this to the right or left based on what I get. Now my phi in this case from the problem is pi. It's not negative pi, because that would be a negative in front of, there would be a plus here, because from the original equation at the top of the page, the phi is always the minus of the problem here, or the subtraction of the problem. So this is going to be positive pi, and then the omega down here is going to be 2. So that is going to be my shift. So let's remember here that in my previous graph, the one graph that I had written in this upper right-hand corner of your screen here, the pi over 2 unit was right here at this mark. And let me actually change colors so you can kind of see what I'm talking about here. Oops, hold on. So this right here is the pi over 2 moment. So what I'm going to do is I'm going to actually start drawing from that place, that up, middle, down, middle. So there's my cycle shifted pi over 2 units. Now what this means is that it's going to continue, but I have to kind of fill in the gaps from where it would normally be. So for the piece that's missing to finish this graph would be this downward little slope right here, this downward part of it. So this now actually finishes 2 cycle, and I'm going to switch back to blue again, but I will show you that we just use our knowledge of how this is moving. This is still 0, 0. And then this right here would be pi over 4, comma, negative 3. This here would be pi over 2, comma, 0. This here at the top would be 3 pi over 4, comma 3. And this here would be 4 pi over 4, or just pi, comma 0. So this graph, this blue graph, got shifted pi over 2 units to the right, which created this new, as you see, a new look to the line. And then we're going to move down here. This is going to be 5 pi over 4, comma negative 3. This here is going to be 6 pi over 4, which is the same thing as 3 pi over 2. Did it again there. 3 pi over 2, comma 0. 7 pi over 4, comma 3. And then 8 pi over 4, which is the same thing as 2 pi, comma 0. So now I'm ready to do the last part of this page and video for you. This is going to be to take this and do a vertical shift of 1. I'm not a big fan of moving the green line. I'm a big fan of moving my points. What this allows me to do is give me a very accurate line, and once I've done drawing this line, like the one on the left here, I will be changing my x-axis, because it's easy to do so, and this also gives me a really nice picture. So what I'm about to do here is just change this, because notice this is 3 units away from 0, so this is -3, -2, -1. So this would be -1, this would be 0. So here, my friends, is the new x-axis. So this will be 0, and this will be 1, and I can make this 2 and 3 if I really want to be fancy here. But what's good about this is I can label all the points at the end of this problem, and the points will be at nice locations. So this is going to be at 0, 1 instead of 0, 0. This is going to be at pi over 4, -2. This here is going to be pi over 2, 1. So you can see that it's going to be the same as the previous picture, except that every single y value will be 1 unit higher. This is going to be 3 pi over 4, 4, and so on and so forth. Pi, 1, 5 pi over 4, -2, 3 pi over 2, 0, 7 pi over 4, 3, and then finally at the end, 2 pi, 0. All right, well, thank you very much for watching, and stay tuned for 2 more videos encompassing this section. Take care.